linear systems by graphing. I've given you the definition of a linear system. It consists of two or more linear functions. In other words, two or more lines. So instead of graphing one line, we're going to be graphing two lines. Solving a linear system means to find a point of intersection where the two lines meet. We're looking for that point where they intersect, okay? Now what we're going to do here, there's 3 steps that you will always do. 1, you're going to graph each line. 2, you're going to find the point of intersection. 3, you're going to check your solution. So those are the 3 steps that you need to always include when you're solving things this way. So find the point of intersection of the following 2 lines. So I have 2 lines. Now this is a very easy question because it's already in y equals mx plus b. Now, I'm going to go for the more efficient way. We're going to use the quicker way. I don't know, what way do you think is very quick to graph? We have 3 methods: x, y intercepts, table of values, or slope y-intercept. Which one do you think is the easiest? Trevor? The x, y-intercepts? Everyone kind of has their own personal preference. I'm going to review our slope y-intercept method. That's x, y intercepts is good. You can solve it algebraically. Your slope y-intercept, it doesn't really require too much algebra. So we're going to review this here. This is already in slope y-intercept form. So I'm going to start around. We're going to go around the U. Joe, what is my slope here? So just 2 over 1. What is my y-intercept, Andreas? 1. So, Curtis, if I'm using the slope y-intercept method, what do? I have my 2 pieces of information that I need. Good? Here's 1. Then what? So I rise 2, and I run over 1. Rise 2, run 1. Rise 2, run 1. I'm going to do backwards. Down 2 over 1. So I'm plotting a couple points to make sure that my line's going to be as accurate as it possibly can be. So you're going to take your ruler. Okay, so there's my first line. Does anyone have any questions about how I graphed this line? Okay, Tiana, what is my slope for the second line? Good, so -1 over just 1. We always keep the negative on top. If it was -1 over -1, that would be +1. Okay, so so it's just -1 over 1. Callum, what is my b here? Very good. Eric, if I wanted to plot this equation, what do? I want to plot this equation here. I know my slope is -1 over 1. I know my y-intercept is 4. I start at what's my y-intercept? Yes. So I start at 4, and I would go, what's the pattern? Down 1 over 1, down 1 over 1, down 1 over 1. So I've just plotted two linear systems. I'm looking for their solution. Jess, if their solution is the point of intersection, where is that? 1, 3. We have to walk into the hotel first, one space, take the elevator up to the third floor. So my point of intersection, my POI, is 1, 3. Okay, now to check your solution, to, that means you're going to check if the point is really on the line. And you're going to do that in 3, or you're going to verify it for both equations. So my first equation is y equals 2x plus 1. So I'm going to sub 1, 3 into y equals 2x plus 1. What will it look like, Trevor, when I substitute my point of intersection into this equation? Okay, yeah, you could, I know y is equal to what? So I can put 3 here because that's what y is. Then 2 bracket 1 plus 1. So my left side, there's nothing to do. So my left side is still 3. Billy, what do I get when I do 2 times 1 plus 1? 3. So I have here 3 equals 3. So it's balanced. So that's my first equation. My second equation to verify that, y equals negative x plus 4. So what would I write when I substitute the point of intersection in for that, Joe? What is y? Okay, again, nothing to do on my left-hand side, so I leave it as 3. What do I get on my right-hand side, Vic? Yep. So 3 equals 3. You've checked it with both equations. That is the solution. Negative 1, 3 is your solution. Any questions? Okay, find the point of intersection of the following two lines. Why is this one a little different? What do I have to do first, Val? Why? What am I doing? Yep. So I'm going to bring the 2 over. So what will I write, Val? Did I move the 6? So it stays just plus 6. Rach, Jeff, what do I have to do next? Good. I divide everything by negative 1, again, because there's a 1 there. Divide by negative 1, divide by negative 1, divide by negative 1. Rachel, how does that simplify? Perfect. Anyone have any questions, or are we okay? All right, Autumn, what is my slope here? Just 2 over. And what is my y-intercept? Okay. Paul, how do I graph this? Okay. Other way around. So I go up 2 over 1. Up 2 over 1. Up 2 over 1. And I'm going to draw my line. Kristen, what do I have to do next? Negative y, right? You left. Good. What do I have to do next, Ida? Not negative 1. Divide by negative 1, divide by negative 1, divide by negative 1. Valeria, what do I have to do next? What? Just x minus 1. Positive and a negative give you a negative. Okay. Joe, what's my m here? Good. 1 over 1. What's my y-intercept? Andreas? Good. Curtis, tell me, how do I graph this? Whoops. Okay. Tiana, what's my point of intersection here? Yep. 5 and 4. So my point of intersection is 5, 4. For time, I'm not going to check the solution, just for time's sake, so we can get through a couple more examples. But to check this, you have to, it's the same thing that we did in the other example. You want to know what? Actually, maybe we will do it. So my first equation was 2x minus y equals 6. Callum, what would I do to check? Good. And Eric, what do I get on my left-hand side when I calculate this? 6 equals 6. So I know my equation's balanced. So the point of intersection lies on that line. Now I need to do it with the second line. X minus y equals 1. What do I have to do, Jess? Good. How does that simplify, Trevor? 1 equals 1, left side equals right side. So I verified that. Ooh. Okay. Let's see. Here is an interesting one. So we've talked about point of intersections for this. I want you to rearrange these two equations into y equals mx plus b. I want you to do that right now. Take a couple minutes and do it. Okay, Billy, tell me, what did you get when you rearranged the first equation? Okay, go through the steps. Good. And then what did you do? Good. How many of you got that for an equation? Okay, good. What do I get for my next equation? When I rearrange that into y equals mx plus b. Joe? Plus 3, right? Negative 6 divided by negative 2 gives me positive 3. What do you notice about these two equations? They're the same. So if they're the same equation, how many points of intersections do they have? All, all of them, everything. We say that this has infinite solutions because the lines coincide. What does it mean when the lines coincide? They're the exact same. So if we were to graph this, because both equations are the same, I start at 3, I rise 1, I go over 2, rise 1, go over 2, rise 1, go over 2. Okay, if I were to do the same thing, the lines would be on top of each other. Because again, I would do the next one here. My y-intercept is 3, my slope is 1 over 2. I'm doing the same thing. The lines are on top of each other. So if I were to ask you, how many solutions does this have? We would say it has infinite solutions because the lines coincide. Which means they're one on top of the other. Okay, so now we've had one solution. We've had infinite solutions. Infinite solution, what's the word that's in there that we're used to hearing? That Buzz Lightyear says a lot. To infinity and beyond. That's how many points of intersection that they have. Infinite, infinity, coincide. Did I coincide? Did I coincide? I'm not a good speller. That's why I'm in math. I'm going to look that up. Okay, next one. The next one here, I'm going to give you a minute. I want you to rearrange this into y equals mx plus b and plot the line. See what you get. Okay, Vic, you're up. Good, so what do you write? Good, what's my m, Vic? Over 1. Good, and my b is what? Good. What what do I get, Val, for the second equation? So what do I write? Good. Divide by 2, divide by 2, divide by 2. So what do I get? So what's my m here, Jeff? Good. What's my b? Anyone remember something special about these lines? Anyone remember, Jess? How do we know that they're parallel? They both have the same slope. And they have different y-intercepts. So I know our graph, this isn't really a good graph because it doesn't show it. If I graph my second line here, I'll start at +3. And then I would go down 3, 1, 2, 3, over 1. Down 3, 1, 2, 3, over 1. Down 3, over 1. There's one line. I don't know why I keep doing that. Let's try this one more time. Okay, there's one line. Now, this isn't a good example for, this is the second line. My y-intercept is 3. My m is -3 over 1. If I were to kind of sketch this, 9 would be somewhere here, 10, 11, 12 would kind of be there. So I would start at 12. I'm not going to put a point there. I'm going to kind of follow this pattern, see where I end up with. So I would start here. I would go down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. Down 3 over 1. So you can just plot these points and take my word that it's on your line. And you can visually see here that these two lines are exactly as Jess said, that they are parallel. And I could tell that they're going to be parallel even before I graph them because these have the same slope. That was a property you learned last year. Now, how many solutions will these have? None. If the lines are parallel, they'll never meet. So we write here no solution. There's no point of intersection. We're going to look at algebraically. What does this mean if they don't have a solution? If they don't have a solution, it looks like something special, and we're going to go over what that would look like algebraically. So if I had here, this is kind of a summary. You have this on your paper, right? There's three types of solutions we can have. One solution, infinite solutions, no solutions. Those are three possibilities. Each of them will look different. So it says graphs of lines, slopes of line, intercepts of solution. This is supposed to be all the way across. Okay, Valeria. So I have the slope, the y-intercept, and the number of solutions. This is how it should read. Sorry it didn't come up. So if I look at my parallel lines, and I'm just going to sketch two parallel lines here. What is true about the slopes of parallel lines, Rachel? That it has the same slope. What is true, Autumn, about the y-intercepts of parallel lines? Pardon? Well, they're not the same. My y-intercept is here. So they are different. So if my slopes are the same, my y-intercepts are different, the number of solutions that I will have is none. Those lines will never cross. So you should be able to tell just by looking at two equations how many solutions they will have. If I have something that looks like this, what's true about these slopes? Trevor? So I have same slopes. What's true about the y-intercept? Powell, what's true about the y-intercept here? Yep. So if they're the same, how many points of intersections do I have, Kristen? It's infinite. So those are kind of special cases when we have parallel lines and when we have lines that coincide, that are the exact same. Our final case, which is typically the one that we're going to see, is if we have two lines. What's true about these two lines? What could you tell me about these two slopes? Ida, are they the same or are they different? So if I have a different slope, Valeria, what's true about these y-intercepts? Pardon? They do? Well, look, here's my y-intercept here. Okay, so they're different. And how many points of intersection will they have? If you have a different slope, a different y-intercept, how many solutions will you have? Trevor? One. Oh, you could. Yeah, you're right. You could have a different slope and the same y-intercept. What's special about that? Not opposite. I'm going to put or the same. If I were to draw this, I'm going to go. So if it has the same y-intercept, so let's go here. The solution would be the y-intercept. These have the same y-intercept. That's their point of intersection. So their y-intercepts could be the same, but that means that it's the point of intersection. Does that make sense? That's a good point. Okay, do you have one more page? Okay, so it says here, determine how many solutions each linear system will have without graphing. So here are my first two systems. What is my slope in the first equation here? Valeria? 2/1. What's my y-intercept? 3. Joe, what's my slope for my second equation? What's my y-intercept? Okay, so I'm comparing my slopes. I'm comparing my y-intercepts. My slopes are what, Andreas? Are they the same or different? And my y-intercepts? So how many solutions will this have? One. Okay, this one here, what do I have to do? Curtis, what do I have to do to help me out with this second example? Pardon? Okay. So what do I have to do here? I'm on the second example. My first equation is already rearranged into something that I like. So how will I rewrite this? Tiana, what do you notice about these two equations? So what happens when they're the same? How many solutions will they have? You're right. It's infinite because they are the same. Callum, what do I have to do here? So I divide by 3, divide by 3, divide by 3. What do I have to do next? Good. So how do I rewrite it? Good. Good. So if I compare here, what's my slope in the first equation, Eric? What's my y-intercept? Jess, what's my slope in my second one? And what's my y-intercept? So how many solutions does this have, Trevor? Why do they have none? Good. Slopes are the same, y-intercept is different. Does anyone have any questions?